Welcome and thank you everybody for coming to this talk. This is IR with the Volatility Framework. My name is Evan Wagner. My Twitter handle is Bun0xd. I've been working in security since 2013 when I started working at Prolexic Technologies. They're the foremost DDoS mitigation service in the world at the time. I got my first domain name in 1999. Started hosting websites and stuff, and I held a variety of IT roles since, such as Tier 3 systems engineer and software engineer too. Senior software architect and security admin and other roles. Has anyone in the room used Volatility before? We got any incident responders in here? All right. Cool. All right. So basically, the way I got into Volatility is essentially I didn't have access to fancy EDR tools at a former company, and I needed something to be able to determine what had actually happened on the machines when investigating an incident. So this seemed to be the only tool at the time. But just a quick disclaimer: these processes bring inherent risk. It should always be performed in a segmented / isolated environment. The tools mentioned in this presentation do not come with a guarantee or warranty implied or otherwise. And the statements made are my own and not that of my employer. Okay. So let's just start real quick and we'll go over what Volatility is and some of the functionality and how you use it. Basically, Volatility was, released at Black Hat / DEF CON in 2007, supported by the Volatility Foundation. There'll be some links in here that you can go to, and they encourage researchers to contribute. They host annual Volatility plugin challenges. And so if you have a really cool idea for a plugin or anything, you should submit it on there or try to get a hold of them and, try to make a plugin and try to get it merged in at some point if you can. A lot of the plugins, there's tons of plugins out there that are not included in the releases on GitHub, like in the standard release. So you can basically go through the Volatility Challenges website and get an idea of what some of the items are that are really actually pretty good that are not included in the default package. It's written in Python, which allows for great, cross OS compatibility. And there's a lot of plugins for the analysts to go over. All right. So why would you want to use Volatility? Okay. So this will give you a verbatim view of the running environment on the machine at the time, depending on the acquisition method. Increasingly malware won't touch the disk. If it does, it's normally temporary and then erased or time stomped afterwards. So, the malware authors and bad actors are going to try to cover their tracks. So, by having a copy of the memory at the point in time, right as you begin your investigation, you really are doing yourself a benefit. There's all kinds of, you can, observe network connections in Volatility, but they're basically going to just exfiltrate data over known, good, reputed sources, so they're either going to launch their attack via the ad network or reputable CDN or, try to exfiltrate over, Facebook, blog, whatever means that they can. There's a ton of cloud providers that are just whitelisted. You could just go to town. The data is decoded out of the image or other source, injected into another process, and then exfiltrated over secure channels. So basically, whenever they go to one of these well-reputed websites, they can just download an image off Blogspot, for example, and then extract the base64 encoded payload, execute that, and then basically it's gone afterwards. The temporary internet files have a lifetime, and it just looks like an image. So, without digging deeper, you're not going to understand how the attack actually occurred. And like I was saying before, when you don't have, tools like Sysmon, which will give you the high verbosity logs, EDR, etc., you really owe it to yourself to learn Volatility, to be able to just, go at the memory image and try to extract as much information as you can. So the package availability of Volatility, basically Volatility by default is distributed as a Python application that you can download off the GitHub URL there. In the examples going forward, that's basically the preferred method. So all my examples are essentially just using the vol.py. You can download the binaries, standalone binaries for the different operating systems at the following URL, and they're pretty decent too. There's also, in some cases, Linux forensic distros that'll have volatility in them. This is the least preferred method because they normally have incomplete profile sets. So if you're running into issues, you can't you're seeing strange characters. You're not all the profiles that you're attempting are not working. Sometimes it's because the profile's not present in that the release that you have. Either it's from if it's from a distribution, typically they don't come with all the profiles. Recall framework. Is anybody familiar with recall framework in here? All right. Yeah. Recall framework is really good for live memory analysis. So when you get on the machine and you can run a majority of the commands that are available in Volatility, they have their own. I don't know if they call it EQL, but there's a query language that they have now for writing queries to select the information. This is good in circumstances where the memory is really large, or you just can't move the memory image. And there's also live memory PMEM tools out there as well that'll basically load a driver to allow you to query the RAM in real time as well. Okay, we'll just go over a few terminology things here. So there's going to be when you're doing memory analysis on a memory image, you need to have the correct profile selected. The profile actually includes all the debug symbols that are necessary to actually understand what a process looks like in RAM, what a network connection looks like in RAM, what an open file looks like in RAM, what a mutex looks like in RAM. All the different things that Volatility searches for. It has to have these debug symbols, or it's not going to be able to display them or interpret them. This is basically the first thing that you have to figure out: what profile is going to load best for your memory image. And there's all kinds of different builds of each operating system release. So I think Windows 10 has at least half a dozen build profiles at this point, and it's hard to keep up with for the Volatility team to keep up with. So if anybody wants to contribute on Windows 10 profiles, that would be cool. The VAD tree, this is the virtual address descriptor tree. It maps physical and paged out memory pages. So it's basically an address space that is mapping to the physical memory when it's still in physical memory, but if it's been paged out, it'll map to the page space. So that way, while you're acquiring memory from a machine, typically, if you're using PMEM, it'll extract more than just physical memory. So if you're extracting the page files and you're extracting hibernation files, you'll want to be able to actually map to the page file itself where the artifact is. Okay, so here's some considerations going forward. What's the total physical RAM size for the machine that you're going to acquire the memory image from? Does it make sense at all to actually dump and pull back a 128 gigabyte RAM image? Can I get the memory back in a timely manner? Do I use compression? And these are all circumstantial to your environment. So it doesn't really make sense, in my opinion, to move the 128 gig memory file. Disk storage. Is there even enough disk storage on the machine to dump the physical RAM? These are considerations you got to consider when you're doing IR on a machine. You can impact the machine by dumping a large amount of RAM, and then it runs out of space, and the computer all of a sudden is not going to function well. Let's move forward. Okay, so we'll go through acquisition methods. So I like the PMEM tool. There's a Linux, OS X, and Win PMEM available out there. The recall repository on GitHub actually has some good releases for PMEM if you're looking for one that's going to work for you the best. I believe there is a bug that was fixed in the Lin PMEM not too long ago that was causing it to download 38 think that there was 38 terabytes of RAM on the Linux machines, which was an issue. It was a crazy bug, but that's been fixed. But these tools are really great. They'll produce an AFF4 file, the Advanced Forensics Format file, and it stores streams. So you can have a stream in there that's literally files from the file system. You can have a stream in there that's the page file. You can have a stream in there that's the physical memory. It's whatever streams that you want to include in there, and you do analysis on later. You can actually extract those different individual streams and work with them. Volatility does not work with the AFF4 files. Recall can work with those files. So that's a consideration too. Running PMEM, here's just a quick example. The output dump AFF4, or if you wanted to dump out a specific stream, you could say -e physical memory o dump.raw. So you can then take the dump.raw and work with that file in the Volatility framework. So if space and time constraints are an issue, then definitely you're going to want to use a tool kind of like Recall or a similar tool. Otherwise, like I said, you'll run out of time trying to copy the file back, or some other strange circumstance. When working with virtual machine images, which I'm sure that's a concern, VMware actually has a tool called VMSS2 Core, and there's the URL for it. And that can take a snapshot file and a vmem file and convert it into a raw mem dump that you can then load into Volatility. So that's a very useful tool, and it's free to download. You just go download off their site. What's really good also is there's sample images on the Volatility Foundation GitHub page. So this is the URL for that. If you wanted to go download any of those, they have some pretty decent ones on there. Okay. So now we're just going to go over the basic usage of Volatility. Okay, so like I said, I prefer to download the package, just a zip file off of GitHub, and bring that down. I just put it in my home directory, and I just execute from there, just tilde volatility vol.py, and that just makes it easier for me. There's also, and we'll get into that, like environmental variables that you can set to make the process a little bit easier as well. So after you've downloaded and extracted Volatility, you're going to want to, you can list out all the functionality and features by just running vol.py, python vol.py-h, and it'll give you an idea of what the supported types of files are, like crash dump files and whatnot, but also the supported profiles and all the different plugins that are available in that version that you downloaded off GitHub. Okay. So list the plugins and profiles that do tac info, and then how when you have a memory image, it's difficult sometimes to determine what the optimal profile build is. So if you run the vol.py-f on the memdump file itself, and then just say image info, it'll give you information about what it can interpret from the RAM image, and via the kernel debug scan plugin will show you and a list of possible profiles that would actually work for your memory image to be able to understand the constructs in RAM. Okay, so when you select the profile, you just do tac-f memdump file, and then hyphen profile equals the name the build itself, and then you type the command. So ps list, for example, here. All right. So now let's get into responding to incidents. Some of the modules that I find pretty useful for doing incidents. Objective discover, malicious process, artifacts, and then dump them out. So here's typically what you'll do when you're trying to get a list of all the processes. You'll run the PS list, the PS tree, PSX view, and the proc dump. So basically, PS list will just show you what will happen in the standard PS list if you were to type it in on your operating system command line. PS tree will actually show the process execution tree. The PSX view is really useful because what it'll do is it'll show you if a process is attempting to hide from PS list and CRSS and other types of processing numeration listing. So PSX view is really good if you're trying to find a process that's trying to hide, and then proc dump can actually just dump out processes. So, Volatility has a really good capability to actually dump out network connections. So if if a machine has been on for 6 months or a year or whatever, it's not going to aggressively overwrite the sections of RAM unless it actually has to. So you can go way back in time with network connections and other processes and everything, and that's very useful if you're trying to investigate something that happened further back in the past. So typical commands would be like conscan, netscan, sockscan, and there's a few others that are available that are operating specific, like for OS X and Linux. Okay, so file handles. Basically, file handles are anything that's opened. A file handle can actually also be mutexes and other artifacts. A network connection would actually also show up if you're invoking the TCP functionality. Will show up as a handle as well. Just won't show you the information about the connection itself. LDR modules is really good. It'll show you the modules that were loaded for all the different executables. That one is very useful, and I'll show you guys here in a little bit how you can use that to actually determine if malicious process injection actually occurred. And then dump files, you can actually dump out all of the file handles that were in RAM. So literally recover all their files that they had opened either currently or in the past that are still present in memory. You can literally say dump files -D to choose the directory, and then the -S will produce a summary file, because if you don't put the summary, if you don't apply the summary argument there, then what will happen is you'll just have a bunch of files that are named as the offset where they were at in RAM. So you want the little bit more context by adding the summary argument there. And then malware, it has some decent capabilities to detect malware. Malfind is really good. What it looks for is the VAD tree protection violations. So they said on there that some VAD tree pages were only allowed read only, but and so if they violate that and they change the property to say that it's read, write, execute essentially, then something strange could be possibly happening there. But there's also a lot of false positives that can happen while doing that. Mod scan, those are the drivers essentially that are loaded by the operating system. Any kind of API hooks, like OS API hooks. Command scan and command line and consoles will attempt to recover some commands that were typed into the terminal. Those are really useful. And timers, like basically scheduled timers that are going off, in the background. That's another way that an adversary could get persistence. And the system's service descriptor table as well, to see if there could be any anomalous entries in there. Okay, so basically, after you've dumped out all these files that we see here, we're just dumping them all out into TXT files, okay? So what we're going to do afterwards is there's a reason that you came to the machine. Like the user says, hey, my machine is exhibiting strange behavior, or an alert fired, or some kind of strange, something strange or anomalous occurred. That's the reason you're looking at this. That's the reason you came to the machine in the first place. And so as you're dumping all these things out and producing these text files, you're gonna want to actually grep across them essentially with whatever your indicators are, if you have indicators. So that's just something to to think about as well as you're going against the text files. And once you observe any kind of indicators, then you need to pivot and start extracting files and providing PID offset context to the commands to be able to get those artifacts out of memory. So now we're going to go over the narrowing on the criteria. So if you actually are dumping out, say that the user downloaded an Excel file or whatever, you can actually tell Volatility to dump files out, and then you can pass in a regular expression and say, I want to dump out all XLS files, I want to dump out all EXE files, I want to dump out all DLL, CSV. You can actually apply that logic there and dump those out. And then when you do find a process specific that you do want to dump out, what you'll do is you'll use the proc dump module plugin, and you'll specify a directory, and then I typically will put the unsafe, right here, the unsafe in the memory, and then I send all the data into another text file that just basically records everything that happened. But if you don't add the hyphen surrounding memory, the executable might be incomplete. So you need to, that's something that you need to be aware of, that you'll need to add that. And there'll be a couple other little, caveats like that, where it's like these little argument switches will just totally change how you use the tool. Okay, and so, alright, so you can also just dump registry out of there, you can dump the cache, you can dump certificates out of the memory, you can dump all the registry hives if you need to go out. You can actually query registry hives directly in Volatility if you know the key path. And then you can dump the hashes out too, when you can basically specify the offsets for the SAM hive where the credentials are at, and dump the passwords out of the registry. All right, is anybody in here familiar with Yara? Anybody use Yara? Yeah, so Yara is amazing. There's so many great Yara rules out there, and it's really not that hard to write Yara rules. They can be high fidelity if you're applying different conditionals to it. But in Volatility, you can either pass a file, or you can just search on your IOCs. So say there was a domain name that triggered on the alert. That's the reason that you're coming at this, this machine. The reason you dump the RAM out. You can basically just throw domain.com in there and under Yara search, and the hyphen kernel and hyphen wide. Now the wide is for wide strings, and that'll search over, not just ASCII strings. It'll give you Unicode strings, and that'll improve your search results when you're searching for those types of strings. But you can also search for byte sequences. Whatever your indicator is, you can find out what processes interacted with that indicator. I find that this is useful if you've been searching around in the RAM, you're using just the plugins, and you're not seeing what you expect to see. Just start searching for them with Yara, and typically you'll land on what you're looking for. Okay, so now we're going to go through a quick memory analysis example here of a machine. We don't know what happened. The computer is exhibiting strange behavior, and systems might be that are controlled by this machine might be failing, or something brought you to the machine, but it's kind of ambiguous. So we're just going to go over a quick example. So here's an output from PS list. Unfortunately, this is pretty small. You won't be able to read it. Wasn't sure how big the screen was going to be. So let's just go to the next slide here. So if we go, hold on. We go down. All right. So, man, can you guys see the red box there at all? I should have made that bolder. So right here, the anomalous thing about this right away. So we have the process. We have the process list. Okay. And so, we're like, okay, well, we don't know what's wrong with this machine yet, why it's behaving the way it is. So what you'll want to start doing right away is like listing processes and seeing what has actually occurred in there. And so you can look on here, it'll show you the start time, the exit time, the name of the process, the PID, the parent PID that started it, how many threads that were detected for the process in memory. And so basically with this, you can see what was running, and then even processes that had been exited. To see when they ran and when they exited. So in this list itself, though, what makes this strange is that we have an LSASS-EXE right here, and we have two more LSASS-EXEs down here. They're not exited either. Okay, so we have three running LSASS processes, which there should only be one. So this is anomalous. Now we're like, okay, one or two of these processes is going to be something strange. And so as we dig further, we're going to encounter, as we analyze them. So this is output from the malfind command. All right. So like I said, malfind will look for VAT address tree protection violations. And so if you look here, it says page execute, read and write. So this page, it's executable, but you can also read and write from it. And can anybody else see anything anomalous with this this output here for the LSASS process 868? Anybody notice anything anomalous? MZ, that's right. So somebody at this page here had injected an MZ, which is a Windows executable header. So this is that's anomalous. You know, when you see things like that, it's either your tool intended for that to happen, or you know, a malware author you know, possibly caused this to happen. So if we go further, I'm interested in this process now, and so I'm going to go over what modules and everything, the file handles. So in this case here, I'm checking the loader module, which is essentially the DLLs that were loaded for process 868. It says right here, unfortunately you can't see it very well, but it's a little red outline, and it says that when the process was initiated, the module wasn't, this DLL was not loaded. Okay, so that's also strange. Okay. So, and it's blank here, there's no path to a DLL. So now, this is where I was saying before, adding arguments to the commands in Volatility, we can increase the verbosity level, and we can actually get the paths of what was injected into that process. So, if we go down here, so this is basically just adding this -v right here. Now we can see what the base load paths were for these DLLs. And so if we go down and we're like, okay, here's LSASS-EXE, expect that. But then LSASS-EXE is the source load path for the DLL. That is anomalous. You wouldn't normally see that. So now it's getting really interesting. I really want to know what, at that point, which if we see here, let's go to, one sec, where the offset is. So in this, we're going to want to now figure out where the offset is for that. And we see that the base address right here is 100,000. So now we want to find out how we can pull that section of RAM out and do further analysis on it to determine what actually occurred there, or what that injected code is actually doing. So here we have, if we want to dump out all the VAD pages associated with the process, which I suggest, because that way you instead of just dumping the process itself, you get all the files that it was using, and the drivers and modules that were loaded in with it. So you can't really see it, but right here, so I'm using the command vad dump. I'm passing the PID to 868, and then I pass a directory capital D where I want to dump out all these pages to, and this is the output. These are all the pages that they're dumped out, okay? And our suspect pages right here. I can barely see it. Sorry about that. Let's go down further. All right. Now here I am. I've gone into the directory, and I'm basically trying to figure out what these files are. All right. So I just run file, aster.dmp, all right, and they're all named essentially with what the address, the base address, and then the offset that they go to. And so this right here, it just says that the page that I'm interested in is just data, all right. So if we continue forward here, now, in my experience, you'll want to figure out if the file has other sections or other portions in it. Sometimes files can embed other files inside of them, and binwalk. I don't know. You guys ever use binwalk? It's a really good tool. If you guys haven't used binwalk, it's amazing. So binwalk can show you if there's compressed elements inside of the file that you've dumped out. It works across all files. Binwalk is, I can very much so suggest that file. So this is the output from binwalk. And you can see here that the page section that I was interested in right here, it actually gave me an MD5 checksum for that page, okay? And so now I can take that MD5 and check that against reputation databases, but I can actually check all of the MD5s that came out and were dumped out from that VAD dump to try and determine if anything was anomalous there, and they show up in the list as well. I just don't have the complete list there. So when I looked at it, I was like, oh, and that says Dooku on it, which is like a variant of the Stuxnet malware. But then you can get an idea, hey, this was the actual output for that MD5 address, or this is what virus total reputation was. It was a 46 out of 70. So it's pretty bad. But now what's going to happen is like, okay, I found the malware on the machine. But when you're doing an incident, you need to figure out how the malware got on the machine in order to put the mitigations in place to prevent it from happening. And so that's part of the whole IR life cycle is, detecting it and then making sure you afterwards have the protections in place to try to defeat or mitigate that type of attack. So, has anybody in here used like timelining tools? Like Plasso or anything like that, or FTK maybe? So Plasso is amazing. Basically what you can do is take a bunch of body files, put them all together from all of your MFT, your memory, we're about to go into the timelining. You can actually run timeline on a memory image and get all the actions that it can discern from the memory image that occurred if the actual date stamp is available, it'll show you that as well. So when you're performing IR, you typically are building a lot of these timeline files and putting them together, and that way you can kind of get an idea of you want to find out what led up to this actually occurring or how this malware got onto the machine. Okay, so now one of the coolest features also is building timelines with Volatility. So, Volatility supports a bunch of different output formats. If you wanted to incorporate timeline data from the memory image into your overall timeline, you can export them as CSV body format, which is like the standard, been the standard format for a while, or Excel files. A really cool feature though that I like is that you can go through the timeline as an HTML, JavaScript quick little web page, and this is actually built into Volatility Framework to produce this. And I'll show you what that looks like here in a sec. So let's go ahead and open up this timeline here. All right, so when you get in here, it's going to start off with, basically the earliest events, which in this case are, they don't have a time for, unfortunately. But, it basically goes from the earliest and then to the most recent. And so what I end up doing in here is, say I have a PID. So we're interested in PID 868, for example. Okay. We can just type that in there, and that reduced our results down to 23 entries out of 4,520 events that were put into the timeline for this memory image. Okay, and so sometimes, this context is a little bit too close, or a little bit too specific. So you'll just want to go to that point in time. And so we got to figure out, all right, when was this process actually started? Okay, so if we go back to the previous page here, one sec. We go up, we can look at the process. The 868 was actually began 2011-06-03 at 04-26-55. So now, to see what actually led up to this malware execution, we're going to want to go into the timeline and see what's happening in that time frame. Okay, so let's go ahead and increase this here. Let's take out our search. This is just a little JavaScript page, JavaScript HTML page that lets you do the actual on key up event that'll update the search filter. So you just kind of step through it a little bit, figure out where the time range is that you're interested in. Let's go back a couple. Okay, and we can see everything launching in here. We can see service host exe, as these events are actually occurring, they're showing up in this timeline in order. Okay, and so, we want to get to the point in time where our malware event process actually executed. So let's go forward. We're getting close here. Notice procmons run. So the user was obviously trying to profile some issue on the machine. WMI is running. So we're getting close to the time here. And now, so these are some timer events that are going off there. But let's scroll up here. So procmon, and then keep going here. Okay, so we're pretty much there. 26, 46. So this is like less than 10 seconds before the malware process executed, there's some user assist actions that occurred in here, and one of them was they ran a file here called 74ddc49a7c121 blah 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 exe, and it was only executed once, and subsequently we have these LSASS processes starting down here, one with a 1928 PID started by 668, which I believe is the services executable in this case. Yeah, that's services.exe. And then as we scroll down, you can see the parent process PIDs. Then we see the 868 at 042655. So shortly after this file here ran, then we got that file. So the next thing also is that you would want to follow up and try to figure out in the machine RAM what process was associated with downloading this file. Was it the browser? Was it the email client? You would basically, now you have to pivot. This is my next artifact, this strange named executable. Now you go through the process again. What process on the computer executed downloaded this at what time? Were there and what web pages were visited if it came out of the browser? What emails were opened, etc., to try to determine the provenance of this malware. Okay, so that's basically, in my opinion, a lot of IR is just trying to trace it back slowly. Essentially, we got to be methodical and identify what's occurring at the point in time for these events that you're seeing. And this the timeliner module inside of Volatility is just excellent. You just have to make sure that when you set your output format, you set it as HTML, and Timeliner will produce the HTML file that has the JavaScript in there that'll let you page through all the results. Anybody got any questions on that? No? Okay, cool. All right. So let's go here. All right. So basically, that's what I had. Does anybody have any questions on this? Hey, sir. Great. So this should work in PowerShell. I believe we had some people using it in PowerShell at the last event that I went to. So you can make it work since it is a Python app. Whatever can run Python will typically run this tool. There's also binary versions, so you can just run the Volatility exe inside of PowerShell to do the same thing, and then pipe it out the way you want to and do all the formatting that you would like in PowerShell. Yeah. Oh yes. The network connections. Basically, it'll show you the full the process executable name itself. It'll show you what the PID is for the process, and it'll also give you the IP address of where it was connected. So the connection scan is really just showing you IP addresses. It's not going to show you domain names. You can dump the cache out of the RAM and see all the domain names that were resolved. You can search, like I said, with Yara against the RAM as well if you have a domain name already to see what process was involved with that. And what I would do is also with the executable, when we identified in the timeline that executable that ran beforehand, if you just put that executable name in the Yara search, you're going to find out possibly what process interacted with that to download it or whatnot. Oh yeah. I believe Glida has a tool. She's on, or this individual's on GitHub, and they have a tool for running the PMEM driver and doing the volatility commands against it. So the person that has scripted it out is the user Glida, GLEEDA on GitHub. And they have a really good example. They dropped out there. Yeah, no problem. Anybody got any questions? Bin walk, yeah. Yes, like binary walk. Yeah, it's a very useful tool and also very useful in CTFs. Yeah, I very much so suggest bin walk. Typically, you just run the sum tool, the one-way hashing sum tool to get the hashes, but bin walk will show you if there's other embedded data in the file itself that it can identify. There's also other really cool tools for extracting data. One of them's if you have page files and you wanted to brute force dump out files out of your page files, you can run another tool called page brute, and that'll do it. And there's other tools that'll work against memory images as well. I believe you can actually also use Scalpel against the memory to extract files as well. So does volatility look interesting? No, so it's super powerful, and like you're saying, being able to run it live against a machine is actually desirable in some circumstances. Like I was saying, when the RAM image is so huge, you can't move it very quickly, and you need to act immediately. Running against live is amazing. Issues I've encountered though with recall while running live, if you're in a highly segmented environment, recall actually goes and attempts to it'll do the kernel debug scan, and it will attempt to automatically download the PDB files from the Microsoft website. Now, if you're in a highly segmented environment, that's not going to happen. That's not going to work. But you can download every single PDB for Windows, I think, as a package, and I believe it's about 2 gigs that you can just carry around with you. But that's pretty cumbersome. So, yeah. All right. So, no further questions. Oh, thanks.